Hey, Algebra 2. We are looking at 2.6, the second part of it. We just finished example 2. In example 2, we had a leading coefficient of just 1 on our polynomial, and we could find, first of all, the list of possible rational zeros was okay, not too many, and we were able to find the zeros or the solutions of the polynomial decently easy. But now we have a leading coefficient that is not 0, which means our list of possible rational zeros is a lot. The p's over q's are way more than when the leading coefficient's just 1. So let's go ahead and try 1 and see how we can get through this. Oh, sorry, very important. When we have a leading coefficient that's not 1, the search for the zeros can be shortened by sketching the function's graph. Okay? All right. Find all the real zeros of this long polynomial with a leading coefficient of 10 and a constant of 12. Gosh, if I just try to make the possible zeros, it's a long list. Okay, let's look at the constant. I have 1 times 12, 2 times 6, and 3 times 4. I'm going to put that under the first option for 10 is plus or minus 1. Oh, I don't have to do the pluses and the minuses. Duh. That'll save me some writing. Now let's do it again. Okay, the same constants give me the same numerator. The same constant gives me the same numerator. Now I've got factors of 10 are 1, 2, 5, and 10. So now we're going to go over 2. Some of these are going to be duplicate, and that's all right. Let's go again. We'll cancel out the duplicates, okay? This is going to be over 5. And the last one. All right, so let's try to find our duplicates. I've got a 1 plus or minus 1 over 1. So let's look for all the other ones that are 1 over 1. That one, let's see, that might be it. Cool, we have a 12, a 2 over 1, which is going to be the same as, so that's a 2. Same as that one, and I think that's it. Yep. A 6 over 1, which is going to be the same as 12 over 2. A 3 over 1, which is the same as 6 over 2 and 10 over 5. We don't have a 10 over 5, though. I don't want to lose anything. A 4 over 1. A 1/2, which is the same as, sorry, this might be tedious for you to watch, 1/2. I don't see any more 1/2s. Cool. 3/2 is going to be the same as 6 over 4. Where's the 6 over 4? There isn't a 6 over 4, duh. 3/2, I think that's it. 1/5. 12/5, none of these are going to be duplicate. And then 1/10. 12/10 is the same as 6 over 5. 2 over 10 is 1 over 5. 6 over 10 is 3 over 5. 3 over 10 is by itself. 4 over 10 is 2 over 5. Okay, everything blue. Those are all our possible zeros. Ooh. All right, so that's step one, list the possible zeros, and that took a really long time. Now, if I go ahead and sketch a graph, which you see right here in the corner, I can choose reasonable values from the list above to check using the graph of the function. So if you look at this graph here, let me get a highlighter. Okay, oh, that's huge, for goodness sakes. Okay, reasonable values is what we're looking for. If I look at that first one, that's going to be between -1 and -2. Between -1 and -2, which that's -1.5. That's reasonable. Okay, that might work. This next one is in between 0 and -1. Somewhere between 0 and -1. Like -1/2 might work. Okay, the negative part of it. Okay, on the other side, we are in between 0 and 1. Somewhere in between 0 and 1. Could be 3/5, 4/5. And then between 1 and 2. Something bigger. I think 12/5 is the only thing big enough. So those are all reasonable. When I graphed it on my calculator, to me it looked like it crossed in a few actual spots, but you know, that this right here gives us a good guess, okay? So I'm going to use those ones I circled on the next slide. All right, so we have our list of reasonable guesses. -3/2, -1/2 looked good. I think I circled 3/5 and 12/5 looked all right. So the reasonable guess. So let's go ahead and check some. So it doesn't matter which one you check first. I know we've got some fractions here and you guys are rolling your eyes at me, but you have a calculator. The calculator work fantastic. All right, so let's try -3/5. So go ahead. I'm getting my calculator out to do some multiplication. Sorry, I just saw a mistake. That should be a 2. So multiply, add, multiply, add, multiply, add, and multiply, add. 8.25 is not a remainder of zeros, so -3/2 is not a possibility. Let's try -1/2. Same coefficients. Okay, hold on. So multiply 1/2 of -1/2 of 10 is -5, -16, +8 would be -34. -17, add, and then +5. Dar. I think I made a mistake. Let's see. I'm double checking my work because I feel like this one should make sense. There we are. 1/2 of -34 is +17. 17 plus 7 is 24. Half of 24 is -12, which is 0. Thank goodness. -1/2 is one of the answers. So I found one. I'm going to write out my polynomial with my factored out binomial and everything else. So we need to remember this. I'm going to put it on the next slide. So far I have x plus 1/2 and then 10x squared, nope, cubed. We started out with a fourth. 10x cubed minus 16x squared minus 34x plus 24. My hope is I can factor this this polynomial without going through that synthetic division again. What I see here right now is a bunch of even numbers. So I'm actually going to factor, I think, a 2 out. And I'm writing it in front of the x plus 1/2, and that's okay. I just need to write it. It's multiplication, so everything is, doesn't matter what order I put anything in. So go ahead and divide everything by 2. And right here I can actually distribute that 2 through that binomial. All right, so I have a leading coefficient of 5 and a constant of 12. I can repeat the steps from the beginning to find my possible zeros. So really I have plus or minus 1, 12, 2, 6, 3, and 4. Luckily my possible values of the leading coefficient are fewer. So that's all going to be over 1, and then we can do the same thing and put it over 5. Two, 6, 3, and 4. So these are all of my possible zeros. Now if you remember, we thought that 3/5 could be one of the zeros. If you look at that graph from a few slides ago, 3/5 is between 0 and 1. 3 divided by 5 is 0.6. When I look at my graph on my calculator, it looks like I can find just by tracing a 0.63. So 3/5 might be right, so I'm going to do that synthetic division again and see if I can get it, okay? I need a new slide though. So 3/5 is what I'm going to put in the box. And my coefficients now are 5, oops, no comma needed, -8, -17, and 12. 5, -8, -17, and 12. Okay, we're going to multiply and add. So 3/5 times 5 is 3, -5, -3, -20, and then 3/5 times 20, thankfully, is -12. So I have x plus 1, x minus 3/5, and 5x cubed squared minus 5x minus 20. Okay, glorious. I'm going to factor a 5 out. And I get an x squared minus x minus 4. And that 5 can distribute through this binomial. It can just get distributed through the first one also. I can just multiply it by something. 5x minus 3, x squared minus x minus 4. Unfortunately, there's no combination to factor that. So I have to use the quadratic formula. Negative b plus or minus the square root b squared minus 4 times a times c all over 2a. So I have 1 plus or minus the square root of 1 plus 16 all over 2. So that gives me 1 plus square root of 17 over 2 and 1 minus the square root of 17 over 2. And negative 3/5, nope, positive 3/5, and negative 1. So I started out with a 4th degree polynomial and I get 4 answers. And that's not negative 1, I'm sorry. I messed that up a while ago. I'm just correcting this if you see my pen moving. If you didn't see what I did, I just put the 2 out in front of there because I forgot it earlier. Sorry about that. Which means this is 1/2. Oh, for goodness sakes. Negative 1/2, 3/5, and then those 2 radicals. Okay, not easy, but not impossible. We're going to try 2 more for guided practice. Okay? All right. So obviously we cannot do both of these on this slide. So I'm going to get a new slide, and we're going to work through these. Okay? They're not going to be easy, but you guys should follow along if you're struggling at all. Okay, all of our P's and Q's. Luckily 3 is small. So I have plus or minus 1 and plus or minus 3. 48 though, goodness. 1 times 48. 2 times 24. 3 times 16. 4 times 12. 5 doesn't work. 6 times 8. Ugh. All right. We can do this. So 1, right? Go again, plus or minus 1, plus or minus 3 over 2, plus or minus 1, plus or minus 3 over 3, which this one I can cancel out. Because 3 over 3 is 1, we've already taken care of 1. Plus or minus 1, plus or minus 3 over, cancel over 4. Oh, for goodness sakes. Plus or minus 1, plus or minus 3 over 6. 3 over 6 is the same as 1/2, which we've already taken care of. Pretty sure that's not going to be the answer, but we're still listing it. Over 24. Plus or minus, oops. So we have over, let's see what we just did, now we 16 and 16. Goodness, I'm still doing it. Plus or minus 1, plus or minus 3. And we're over 12 and 12. 3 over 12 is the same as 1 over 4, which we already have, so I don't need that one. And over 8 and over 8. So lots of possibilities for this one, which is super crazy. All right. So I had all those options, and I graphed it really quick, and I see 3 possible solutions. These 3 possible solutions, I'm just ballparking here. I don't know, one is super duper small, so that could be one of the small ones. So this first one is super duper small. The next one is a little bit bigger, about 1/2. And this negative one, around 3/4, negative 3/4. So let's do a little bit of testing. Let's see, I need my equation, I already lost it. Let's go ahead and test 1/2. No rhyme or reason. My coefficients, 48 4, negative 20, and 3. Half of 48 is 24, add half of 28 is 14, add half of negative 6 is negative 3. Yahoo! So I get really excited. So I have x minus 1/2 and 48x squared minus plus 28x minus 6. And I'm to x squared. I don't think I can factor anything out. No, I'm going to go straight for the quadratic formula. These numbers are really big, and I don't know if I can work with them. So for this trinomial, I'm going for the quadratic formula. Negative b plus or minus square root b squared minus 4 times a times c all over 2a. Okay, 28 squared minus 4 times 48 times negative 6. That's huge. I get negative 28 plus or minus the square root 1936 all over 96. Okay, I could probably push pause and do this math, but I'm going to talk mindlessly and let you listen. I just did the plus, and I got math frac. I got 1/6. Was that one that we guessed? That's the super small one, haha. And then negative 28 minus square root 1936 all over 96. Negative 3/4 and positive 1/2. Those are my 3 zeros. Boom, we did it. Okay, number 6 in your guided practice. F of x equals 2x to the 4th plus 5x cubed minus 18x squared minus 19x plus 42. Oh, we're looking for 4 zeros. All right, I went ahead and graphed this one, and I'm looking for 4 solutions. I'm really excited because this one right here I can read without finding any zeros or solving. So I can do the P over Q. We're going to get factors of 42 over factors of 2. But that's a lot because 42 is 1 times 42, 2 times 21, 3 times 14, 4, 5, 6 times 7. So we're going to have plus or minus all those things over plus or minus 1 and plus or minus 2. What's cool is this one right here is the number 2. So I'm going to go ahead and reduce this and see what happens. I'm going to divide by, it's a negative 2. 2, 5, negative 18, negative 19, and 42. So multiply, negative 4, 1, multiply, add, multiply, add, and multiply, add. So I get x plus 2 and 2x cubed plus x squared minus 20x plus 21. I'm sad because I cannot go any further without some help of the p's over q's. Okay, so 2 was one of them. Moving to a new slide. So we have factors of 42. over factors of 2. So we have plus or minus 1 and plus or minus, no, I don't need to do plus or minuses. Blasted. 1 and 2 over 1 and 2, that cancels. Over 1 and 2. Over 1 and 2. 6 divided by 2 is 3. I already have a 3. 7. 14. 14 over 2 is 7, which I already have a 7. Okay, I think our numbers are getting too big the further we go. Like if I look at that graph, I'm looking for, I had -2, and then I have a little more than -3. So this right here, 7 divided by 2 is 3.5. So let's try -3.5. Okay, I'm totally guessing. My coefficients were, hold on, 2, 1, -20, and 21. 2, -7, add. Add. That's not going to work. Nope. All right, I need a new slide. So I think we're not quite 3 and 3.5. A little closer to 4, so I need to go through a few more of my trials. All right, if you rewind back to the graph that I drew, it's over here on the last slide. I didn't draw, but it's there. I'm going to shoot for one of these. I already hit one of the negatives. I can't find that one. I got this one. That was the one we did on the last page. So let's try one of these. I'm going to shoot for 3/2 for one of those and see if that works, but I need a new slide. So I'm going to use the same coefficients, but I'm going to divide by 3/2. Not in yellow. 2, 1, -20, and 21. Okay, 2 times 3/2. I've got 3, add. I can't add. 4 times 1.5 or 3/2 is 6. Add. And now I'm in blue. Oh, thank goodness. So I have x plus 1/2, x minus 3/2, and then 2x squared plus 4x minus 14. And a quadratic formula. Negative b plus or minus b squared minus 4 times a times c, all over 2a. So -4 plus or minus the square root. 16 minus 4 times 2 times -14. 128 all over 4. So I'm just going to crunch those numbers. Hold on. There we go. Sort of painful. So I have 1, 2, 3, 4 solutions to a polynomial of 4th degree. Whew. I have some extra practice ones for you. All the possible zeros is what we did on part 1 lesson. So I got plus or minus 1, plus or minus 2, and plus or minus 4. You wish it was that easy now, right? Find all the zeros, got a little harder. -2, 1, and 4. And then finding all the zeros, 3, -3, 2, and 5/2. And then here we have just plain old 4. Cool, good work. I know that's hard. I know it is. You guys are awesome though.